black carbon is rather unique in that it's an extremely efficient absorber of sunlight. So it has heating impacts on the atmosphere, unlike most aerosols, which just reflect light and cool the atmosphere. So your sulfates and sea salts, for example, are going to be cooling. But black carbon, in addition to being strongly linked to anthropogenic activities, will heat the air wherever it is.
So in terms of air quality, it's a fairly small aerosol, so it makes up a fraction of that, the particulate matter that's less than 2.5 microns, the PM 2.5. But it's also considered to be like the second most important climate forcer after carbon dioxide because it is black, so it actually absorbs light from the sun, and then it heats up the atmosphere, and it can also change the surface albedo, so basically how reflective the surface is, so it can deposit onto things like snow and ice and make those things melt faster. So it's a fairly small aerosol. It comes from basically any time that you have incomplete combustion. So it can come from things like forest fires, coal burning, things like that. But it can also come from car emissions. And
the diesel traffic is one of the very large sources of black carbon there. So other sources of black carbon include forest fires, agricultural burning, and there's some evidence there was a fair amount of that during KORUS.
So it's complicated in that it can come from both these anthropogenic sources as well as these non-anthropogenic sources like forest fires. And so in terms of air quality, because it's a very small aerosol, it can actually get very deep into your lungs, and so it has implications for your respiratory system. It can also cause more cardiovascular issues.
When we're looking at the importance of black carbon for climate, the first order step, the first thing you think about is how much sunlight does the black carbon absorb directly and then deposit in the form of heat into the atmosphere.
It actually absorbs light from the sun, so it's actually going to change the thermal profile of the atmosphere, so that can affect other things like how the vertical distribution of other species, and then it can also impact clouds. So if you have a lot of black carbon, the clouds might evaporate faster because they're locally heating the atmosphere. It actually causes the surface to be cooler though because it's warming the atmosphere. So you get this sort of surface dimming effect.
And people try and estimate that based on model estimates of black carbon's distribution globally and its distribution vertically and its optical properties. And what they find is that black carbon taken alone, without all the other materials that might be emitted with it, is really a very significant forcer of climate.
Unlike some of the air quality effects when we're thinking about climate, we actually have to consider the whole atmospheric distribution of black carbon, like from the ground up to the top of the atmosphere. So we're interested not only in the sources right at the ground, but also the sources of the black carbon that comes at, say, 2,000 meters or 4,000 meters, because those are going to have different effects on the climate.
So we obtained very interesting data on black carbon using this instrument, which detects the black carbon mass in individual particles. We used two different instruments, one of which was dry and one was humidified to about 80% relative humidity, so that we could look at the same population of particles under dry and humid conditions, so that we could speak to the water uptake by that population of particles.
Using the aircraft campaign, we're able to look at the whole vertical distribution of black carbon, which gives us a better constraint than what we can do with just the ground-based observations alone.
On the KORUS-AQ field campaign, we had quite a bit of information about different aspects of black carbon. So certainly we have the basic measurements of its concentration, and that's providing some value for understanding for example, the different impacts of transport and local emissions of black carbon influencing Seoul and the Seoul metropolitan area during KORUS.
So we do see influences from China and I guess just East Asia in general is the most important source region for anthropogenic black carbon.
So black carbon, because it's short-lived, it only stays in the atmosphere, let's say something like a week on average, is very much the focus for policy interest in order to improve both health outcomes and potentially climate change.